Good morning, everyone. So, I think in the last lecture you have solved the examples. We have solved values of A1, A2, A3, uh, then B1, B2. I think we have found A1, A2, B1, B2, B3. The remaining values I hope you have found. I will write down directly what is g of xt. So you have to verify whether your uh, Green's function, whatever I have written, is correct or not. G of xt is equal to x square into bracket t square minus t by 2 minus t cube by 2. So in the one bracket plus x cube 1 by 6 minus t square by 2 plus t cube by 3. This is in the first interval, say 0 to t, and the next green function is exactly same as above, but instead of t it is x, and instead of x it is t. I hope you understand. Here it is t square x square minus x by 2 minus x cube by 2 plus t cube 1 by 6 minus x square by 2 plus x cube by 3, and this is in the interval t to 1. Okay, you have to verify whether whatever the values of constant term you have found is correct or not. Let us go for one more example. This is about Sturm-Lewis problem, this which we haven't seen up to now. So we will construct the Green's function of this problem. Construct the Green's function of the boundary value problem. What is a boundary value problem? Y double dash minus y is equal to 0. And what are the boundary conditions given to us is y of 0 is equal to y dash of 0 and y of 0 is equal to y dash of 0. And the next boundary condition is combination. That is y of L plus lambda y dash of L is equal to 0. Okay, so these are what the boundary condition. Up to now we have seen the boundary condition of the type it is given with some constant number, but here they are given some relation in themselves. That is y of 0 is equal to y dash of 0 and y of L is plus lambda y dash of L is equal to 0. Now before that, first we have to verify whether Green's function exists or not. So for that, first we'll find out the solution of this equation. How to find out the solution? For this, we can have r square minus 1 is equal to 0, which implies r is equal to plus or minus 1 is a solution, and hence y of x is equal to, we can write it in the form of a e raised to x plus b e raised to minus x, which is what the solution of our equation. Now as we are going to use y dash also. For finding the values of those constant, let me evaluate y dash also. Y dash of x is equal to a e raised to x minus b e raised to minus x. Now let us use the initial conditions. Y of 0 is equal to y dash of 0. So wherever you have x, you have to put it as 0. So a e raised to 0 plus b e raised to minus 0 is equal to a e raised to 0 minus b e raised to minus 0, which means that a plus b is equals to a minus b, which implies this 2 times b is equal to 0 since a will get cancelled, which implies b is equal to 0. So from one boundary condition we are getting the value of b as a 0. Now similarly let us evaluate the second condition. What is the second condition? Y of L plus lambda y dash of L is equal to 0. Y of L plus lambda y dash of L is equal to 0. What is the y of L? A e raised to L plus b e raised to minus L plus lambda a e raised to L minus b e raised to minus L equal to 0. Now as already provided that b is equal to 0, we get a e raised to L plus lambda a e raised to L is equal to 0, which implies if a is outside and and if I write here e raised to L plus lambda e raised to minus L equal to 0, we know that this term will not be equal to 0 since e raised to x is non-zero graph, and so we can have the product of these two is 0, which implies a equal to 0. Is it fine? So now we can say now the Green's function exists and is given by. So this type of a problem is a Sturm-Lewis problem in which the boundary conditions are given with some constant lambda and all. Okay. These are one more examples of Green's function with the help of a first chapter method. What we have seen in that boundary value problem can be converted into Volterra integral equation and initial value problem converted to Volterra and boundary value problem converted to Pareto. So simply we have seen what is g of xt will be equal to a1 e raised to x plus a2 e raised to minus x in the interval 0 to t, and in t to l it is b1 e raised to x plus b2 e raised to minus x. Now we have to find out the values of a1, a2, b1, b2. Again we have to follow the same procedure. What is the procedure? As it is simply y double dash, we have to follow the procedure that g of xt is a continuous at x equal to p. Okay, g of xt is continuous at x equal to t. Now suppose if it is third order differential equation we have been provided, suppose it is of the form y double dash plus lambda y is equal to 0, or it is like this. So we have to verify g dash also. G dash is also continuous at x equal to. But now in this case we will verify this one only. G of xt is continuous at x equal to t. Next, what is the next condition? G dash of xt is having a discontinuity of order minus 1 upon p of t. What do you mean by minus 1 upon p of t? P of t is the coefficient of highest order derivative. Now we can see coefficient of highest order derivative is 1. Okay. So be clear for that. You have to check the continuity. If suppose it is fourth order differential equation that we have seen in the last lecture. So you have to check the continuity at g, g dash and g double dash. and discontinuity for g triple dash. Okay. Now this we are not going to check since it is second order differential equation. So we have to equate them. A1 e raised to x plus a2 e raised to minus x is equal to b1 e raised to x plus b2 e raised to minus x, and hence we can have, or you can write here, g1 is equal to g1 of xt is equal to g2 of xt. Now we are checking at x equal to t, we can write it as b2 minus a2 e raised to minus t. We are checking the continuity, right? b1 minus a1 e raised to t plus this term is equal to 0. So you can name this as equation, say 1, so that we can solve this equation. Now let us go for the second condition. What is the second condition? Derivative of g has a discontinuity of magnitude 1 upon minus 1 upon p of t. So let me write down the derivative of g2 with respect to x minus g1 with respect to x. We are evaluating this at x equal to t is equal to minus 1 only. And if p of t is 1. So let me evaluate the derivative of g2 with respect to x. What will be the derivative of g2 with respect to x? It is b1 e raised to x minus of b2 e raised to minus x. Now we are evaluating this as x. This is what e1 e raised to x plus e2 e raised to minus x. It is equal to minus 1. At x equal to t we have to evaluate. For that we can write this as, I will take the terms of e raised to x common, putting x equal to t. So this will be b1 minus a1 e raised to t next. We can take a negative sign outside and we can write this as e2 minus become plus. Again if we take outside, it is e2 minus a2 e raised to minus t equal to minus 1, which is say equation number 2. We have to evaluate this one also. Since we have 4 unknown, that is a1, a2, b1, b2, we should get a 4 equation. Now what is the last condition? The Green's function must satisfy the boundary. Green's function must satisfy boundary conditions. So what we can write now? The g1 must satisfy the first boundary condition, y of 0 is equal to y dash of 0. g2 satisfy the second boundary condition, y of l plus lambda y dash of l equal to 0. Okay, so here we can write now, this is what our g1 of x. First we'll write g1 so that we can find out g1 dash also. g1 of xt is equal to a1 e raised to x plus a2 e raised to minus x. g2 of xt is equal to b1 e raised to x plus b2 e raised to minus x. So first we will write g1 of 0 t is equal to g1 dash of 0 t, just like this condition. What will be g1 of 0 t? It is a1 e raised to 0 plus a2 e raised to minus 0 is equal to a1 e raised to 0 minus a2 e raised to minus 0. And hence we get this is of the form a1 plus a2 is equal to a1 minus a2. This a1 will get cancelled and v remains with 2, a2 is equal to 0, which implies a2 is equal to 0. Now let us verify the second condition, that is g2 of lt plus lambda times g2 dash of lt equal to 0. What is g2 of lt? It will be b1 e raised to l plus b2 e raised to minus l plus lambda, and now we have to write the derivative b1 e raised to l minus v2 e raised to minus l. I am writing the directly derivative. Okay. Now we can take the terms like e raised to l. If I take a common, what we remains is b1 minus lambda times okay. If I take b1 e raised to l common, we remains with 1 plus lambda. Right. Plus if I take b2 e raised to minus l common, it remains with 1 minus lambda, which is equal to 0. Now we have to name this as equation. Say this is equation number 3 and this is equation 4. Right. Now whatever the equations we have to evaluate those equations. Now in the equation 1 and 2, what we will do? We will substitute b1 minus a1 as some constant c1. And b2 minus a2 is some another constant c2. Okay, rewriting the equation with b1 minus a1 is c1, b2 minus a2 is c2. So this equation 1 and 2 you can see here. This is equation 1, this is equation 2. You can write this as c1 e raised to t plus c2 e raised to minus t. This is what our equation 1, which is equal to 0. The second equation c1 e raised to t minus c2 e raised to minus t equal to 0. Now we have to evaluate these equations. Solving these equations for c1 and c2, it is easy to solve. I will write down directly c1 is equal to minus e raised to t by 2. C2 is equal to 1 upon 2 e raised to t. So in this way, we get the value of b1 minus a1, right? Because we have substituted the value of c1 is b1 minus a1 is c1, so which we get the value e raised to minus t by 2. This is b2 minus c2 is equal to e raised to t by 2. We can have from the equation 3 value of a2 is 0. Right, so hence directly we get the value of b2 is equal to e raised to t by 2. Okay, so value of a2 and b2 we have found. Simply we have to find out a1 and b1. So after doing some calculations, we can get the value of a1 and b1. Do that. I will write down directly what is a Green's function for this example. Or in another way, I will write down b1 and a1 so that you can evaluate this. b1 is equal to, after doing the calculation, solving the equations, we get b1 is equal to minus 1 by 2, 1 minus lambda upon 1 plus lambda e raised to t minus 2l. Similarly, we get the value of a1 very similar plus e raised to minus t by 2. The same thing just like this plus e raised to minus t by 2. Now you can construct the Green's function. Many more examples are there. You have to solve those examples for constructing the Green's function. Now we'll solve the boundary value problem with the help of Green's function. That means up to now we are only constructing the Green's function. Now we'll construct the Green's function and then we will solve the problem. Okay. Using Green's function, solve the boundary value problem. As you're not going to appear for the physical examination, so it is not compulsory to use a Green's function if the question is like that, or if suppose they ask what is the value of a1, a2, at that time it will be difficult for you. You have to use the Green's function so that you can find out the values of a1, a2, b1, b2. Y double dash plus y is equal to x. And what are the boundary conditions? Y of 0, y of pi by 2 is equal to 0. Okay. Now I will not construct the Green's function since it is easy for that. We have solved many more example constructing the Green's function and all. So I will leave this work for you. I will simply write directly what is Green's function g of x t is equal to cos t sin x and sin p cos x is within the interval 0 to t, and this is t to pi by 2. Now we have been provided with the boundary value problem. What is a boundary value problem? Y double dash plus y is equal to x. So the Green's function already constructed. Now we have to find out the solution. The solution is given by y of x is equal to integration 0 to pi by 2 g of xt pi of t dt. So that now what is phi of t in this result? So we get whatever the function exists on the RHS, that is y double dash plus y is equal to x. Okay, so whatever x we have, that instead of x we have to write it as t, since we are writing phi of t. So here phi of x is equal to x, or if you are going to take it on RHS, so it will be of the phi of x is will be equal to minus x. Right? Whatever the terms are there except y, this we can name it as phi of x. This is minus x, so which means phi of t is equal to minus t. And hence we get phi of x is equal to integration 0 to pi by 2. Now this 0 to pi by 2 we have to divide in the two form now. So how to divide? It is 0 to t, 0 to x, and x to pi by 2. Okay. Putting this minus sign, we can have this is 0 to x. The first one g1 of xt t plus x to pi by 2 g2 of xt into t dt. As we are integrating with respect to x, with respect to t, so that's why I have put up the limit 0 to x and x to pi by 2. Simply we have to evaluate the integration, putting the values of g1 and g2. In the interval 0 to x, what is your g1? Sin t cos x. This minus sign we can merge out inside, and we can have this phi of x is equal to minus the integration 0 to x. g1 is sin p cos x into t plus, minus, if I multiply this minus inside, this is what x to pi by 2 cos t sin x into t dt, integration with respect to t. If I take cos x minus cos x common, 0 to x t sin t dt minus sin x, integration is within the limit x to pi by 2 t cos t. Now we have to evaluate this integration of t sin t and t cos t with the help of integration by parts. And then put up the limits. Okay, you can do this integration by parts. I will write down the direct answer for this. Y of x is equal to, we get the final solution, x minus pi by 2 into sin x. Okay, after evaluating both the integration with integration by parts, this t sin t, t cos t, I hope everyone knowing what is integration by parts. Solve it and then we get the solution. Okay. Thank you.